Hello everyone. So welcome to day 20 of our 100 days of DevOps journey. Yesterday we have seen a practical implementation of how a full stack application can be deployed. Though there was some issue in the connectivity part from the front end and back end. So there was I tried to troubleshoot it but didn't get much time. In the meanwhile, there was though I have tested one thing about this. Added one more path. So here you can see you have reached backend home if you are able. But I have added over here. In fact, I'll show you the code as well. So where did it go? Yes, in backend app.py. Here I have added one path, and yes, we have exposed so backend is the API. Though what we can say, I think I have one extension over here. Uh, Let me check if I have Postman. Postman. Yes, I do have Postman. Uh, 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 what is it? Just a moment. Let me install a new one. So there are multiple other tools as well. There is one extension that I'll tell you, VS Code. So you can check. Postman would also be available. Post it requires account. The client do not require anything. Okay, I'll just create to date. No, let it be. Warning: the free version does not support using VS Code. Let me just create a Postman account then. I'm not sure if I have any Postman account available. Content type API JSON. Here you can provide in header section. You can provide everything. Okay, what are the content types? What is the response? I'll just let me close this. Put it over. Why is it not working? Okay, let it be. Key would be content type. Content type would be application JSON. JSON is our content type. Okay, key value. Then what user name? Let us say John. Raw. I don't know, something went wrong. Cache control except. Okay, there are 400 post API bad request. Something didn't go well over here. Parameters, headers. Let's close it for now. One more thing then. We have post request 1 and 2, 168, 1.100. User already exists. So if we have created it, I just want to check it through this Postman. So first of all, let's just check content type, application. It was content type, application JSON. Oh no, it is not correct. Test body. initialization parameter. So yeah, bad request. Again, it is a bad request. Value description. I think headers are the correct place. But in header it is showing us bad request, right? Just close it for once. Go back to header. Just reviewing these. There is some issue with my Postman. Let me just check if I have Postman available in my system itself. Anyhow, I'm able to connect through this through my what we can say curl command. Okay, let me just check if I can check for the login content type. Just remove this email section over here. Okay, and here I got this access token. Okay, okay, user successfully registered. User already existed. Okay, and let's say so we have two users. That is fine. Now, if I could check, I'll try to upload something using this. We have register, we have login register, and there are create a post. So there is this command also. Okay, then we have where was the token? Hyphen E. First of all, let's check if we can log in. Okay. Invalid option. Wait a minute. PSQL password. And here we have PSQL hyphen U. User. Host port username. Oh, capital U. It is capital U. I actually have capital U and then capital W. So our password will be this. Database demo user not exist. Okay. DB name hyphen D hyphen. Wait a minute. I'll just username equal to demo user. Just a moment. Select star from or show tables. So yeah, we have our table like is public post ID sequence user. Let's just see. Select star from user. You can see this my first post, so we have created this. And where are the users, by the way? I want to see the usernames. So table definition columns. Hmm. ID, username, email, and here we have. There is one more thing. Let me just check. Actually, I forgot so many things over here. Since I was not, there are some method to list databases. List databases. So we have DemoDB, Postgres. Owner is demo user. Okay, that is fine. Template. And there is list database. Connect to database -c. Just a moment. So as of now, we have this much of data. The data is getting registered though, but in database, let me just get out of this command. And posts are getting created successfully. I think there is one thing. Users DemoDB is where the user should be registered. App.file register. New user set password data. DB setup. Init DB. New user. Let me just create another one because it is saying that my user is already existing. This user already exists, it says. First of all, let me just check if we have any other log going on. Login is working. Yeah, the one that we have pulled. Docker logs -f Postgres. here we are. So here we have our user email and password. So there is I have to change that particular query. So here this is from public user. So yeah, now you can see over here. Okay, similarly we have like public dot post. Okay, and here these are the post IDs of all that. So yeah, now we are now we can say our data is getting registered. Let's just add some more users, like what was that curl command? Register new users. This user already existing, and we have re Adam. Localhost, I think localhost will also work because it is running currently in the same server. And Bobby. Oh, okay, yeah, there is one issue. Email is the same. Yeah, now it is successful. Then we have Charlie. So let's just check if our users are getting updated or not. Yeah, here we are. John, Harry, Adam, Bobby, Charlie. So all of these users are added. Now let's just do one exercise, one thing. What I'll do, Docker rm-f Postgres. Enter. I have deleted the container. Okay. Our backend might have been, yes. So it has written the it has written the code. Okay. It has updated the application. But now if I'll just share any one of like a curl request, yeah, bad request, internal server error. Why so? Because our this backend I said our database is currently not working. Yeah, fatal error. So this is for the database backend. Where this is our backend running. So yeah, 500 error. Okay, right now backend is not running. Let me just restart our server. Docker compose up -d. So backend is being running. So now only database we have started. Okay, let's just share. Yeah, username already existing. So if I just go in this particular Docker container, I think where was the command? psql -u would be demo user -d would be, what was that? Demo db. Yeah, we are here now, and let's just select star. Okay. So yeah, all of our data is retained right now. So that is because uh, we have used the what we can say persistent storage. Okay, we have used Docker volume to store this data. So here we are. So let's just quickly jump to some of the best practices that we should follow. So right now it is working. This application is like I have created it using just there was not much time for me, and only the Flask API that I have paid attention on. Though for Flask, no, not the Flask, but this front end React.js front end. So due to some limitation in my front end capabilities, front end development capabilities, I couldn't able to do that. So I'm just working on that. Maybe in some time we can have this application to be created. Okay, so let's just do one thing. Let's just go through some of the best practices that we should follow. Okay, so first thing is like let me just go over here in front end Dockerfile. Here you can see there are two stages. Okay, stage 1 and stage 2. So let me Docker images. Okay, so here there are so many images that are being created. So these are the dangling images, we can say. It does not have a name or tag, but like it these are used for the as a cache for these two images. Okay, here you can see the size has increased significantly. Okay, here you can see size has increased significantly. So everything have their own. And if you just say here we have Python, we have Node. So Node is 0.09. Okay. However, our front end image is only 0.43. So in case when there is high agility is required, high agility, like we have to deploy very rapidly, and this size matters. Okay, so size of any particular VM, any particular image should be small, and wherever required, like we haven't used any of very low configuration images. Let me just show you over here. Like we have seen Python slim Docker image. Okay, so if I just go over here, so you can see I think we already have copied it. So in Python we have this bullseye slim. How much storage it requires? 120 MB. However, this Python requires 0.2. There might be some error that we also have faced error in this particular in our image building part when we use this particular image, but that's because it does not have that much those like dependencies to run this application in that, or to yeah, to run the particular application. So what we can do, we can install only necessary dependencies, necessary packages in this particular image. So it will be still lightweight. Image should be the images should be very lightweight over here. Okay, use official or verified base image, like here you can see we are using, this is verified. Okay, Docker official image. Okay, use this kind of images, because these are created by a large community, and there are so many checks and balances, and if there is some kind of like we can say some issue comes up, okay, some bug come up or some vulnerability is detected, so there is a whole community behind, a huge community behind this to patch that. So yeah, that is one thing. One part is use official images. Okay, I'll just add it over here. So this is for Docker best practices. Okay, these are Docker best practices, and let me just okay, use official verified images. Okay, avoid using random images. Then there is keep images very small. Okay, small images are very agile to run, like there are Alpine variant, okay, slim variant, bullseye slim, then bullseye slim, and which one was that? Bullseye, and I think Alpine we have slim bullseye, and then yeah, slim bookworm. Okay, these are some of the very small images. In fact, I'll just show you slim bookworm. What it is, just the size. If I just go, so we have already compared the size, right? Then if we are using, instead of using a full OS, just use very minimal, and then add dependency on top of that. So you might get it would be a large work, but it is only one time, and your image would be. So what it will do, it will remove all the container images which are Docker compose build. Okay, if I run Docker compose build, so what it will do, it will build again. Okay, and save this in the, right now cache has been deleted. Okay, it will take time, but these are like it will keep your workspace clean. Okay, and the caches would be cleaned up afterwards. So there, if there is, right now it is my personal system. Okay, but if there is some kind of like a shared system available, or okay, leverage multi-stage build. So what happened here, if you can witness one thing, so here our nginx is wait a minute, we have used node is this much. Okay, 1 GB, over 1 GB, and nginx is 142 MB. So what happened over here in front end, only 1 MB of data, which is like the build. Okay, the build from the, what we can say, the artifact from this particular node container is built in node, and then one only images. So yeah, there are these two images have been created right now. Okay, these two images have been created. So there is one more thing, Docker compose build hyphen yeah, no cache. Okay, first of all, I'll just prune those dangling images. Okay, cache has been cleaned. Images only, why is it still, okay, 2 hours ago, I think it is still taking. Okay, let it be. So there is, if no cache I'll use, so there's no cache. It will take time, it will take some time, like in this stage it will take time, but it won't create this kind of dangling images. So that if you have like a public server on which you install, you deploy multiple times, or in dev environment, a shared dev environment, so there might be chance if you use this kind of image, and if someone can have access to that, so that person, or that particular, what we can say, unauthorized user can access your image and other skeleton. So it is very good to use these kind of no cache and other commands. It is taking time, but it will fix that. And one more thing that I made right now, if I just show you. So what I have done over here is in Docker Compose, I have used, like, I have hard coded secrets, okay, hard coded sensitive data, username, password, DB, and then this particular URL, okay, this database URL that we have created. So all these data are hard coded even in the code itself, okay. There are, if I'll just show you, even in the code. So for developers it is not very recommended to hard code these changes, okay. So super secret key, so it is hard coded thing, so we should not use it like that. So there is always use some kind of env file. We'll move ahead with that, and we'll just have some kind of so we'll be this is our very first deployment that we have done, and I'm planning on developing this particular application further on. So if I find once it is fixed, then we'll have a proper we'll have a production level deployment. So we are only 20% in this journey right now, and there is a lot of things. Even if we complete our 100 days, and there are some of the topics that are left, I'll surely will share with you guys. And yeah, so and yeah, one more thing here. So right now, since we are using this Docker Compose build, okay, Docker Compose build part, Docker Compose build. So there, if you can see, we do not have Docker images proper tagging, okay. Only one here you can see over here, like, yeah, 12 seconds ago. So it is using only latest tag, okay, only latest tag it is using. So what is the issue over here with that Docker images? 4 minutes ago, 30 seconds ago, 31 seconds ago, 2 seconds ago. Okay, she should have cleaned this. Okay, let it be. 1 minute, where did it go? So yeah, so right now here in this we have provided proper versions, okay, SM backend, this version, SM, these are the versions. Like here we have used slim, this slim bullseye, okay, slim bullseye as the base image. So this is the version. So it is, it should be identifiable, okay. Your container images should be discrete and identifiable when you see over there. So yeah, like here Python, this is slim bullseye, so it is a very elaborative, like this tag, okay. But here in latest, so whichever latest update comes up, okay, it this latest tag would be passed on to that. So in that case, here, like in our Docker Compose file, where did it go? Yeah, in Docker Compose file we are building it, but we can also provide some kind of tagging in that. We'll discuss later on. And so yeah, use tagging, use proper tagging, okay, use proper tagging. And then there is very important thing over here. So if you have seen in this, so this is Python bullseye. Just open this very first one, okay. It is 4 days ago we have created it. And if you go to vulnerabilities, okay, so check this vulnerability, okay. We have this kind of so earlier I have mentioned that security should be in your plan from the day one, okay. It is, you can implement security on top of uh, you have created something like a very uh, it is a functional application, okay. It is a functional application, but the security of that particular application is not very up to date, okay, up to the mark. So what you will just add shell on top of it, okay. Add shell on top of that particular application, that a secured security shell, okay. So once that shell is breached, your application is vulnerable. So security should be, there should be multiple checkpoints, okay, in an application. So that like right now we are talking about the microservice architecture, okay. How does microservice architecture is working? Like API gateway, we have an API gateway, okay. So let me just use this is, okay, this particular is the API gateway, okay. And behind that you have multiple things running on, multiple containers. Like here we just have created React.js, okay, React.js, then Flask API. So there are different containers, even more than these, okay. Let's just go, let's just see, like login authentication. If you are using, your application is using some third party vendor, some third party data, so there would be some integration for that as well, and other things. So suppose if your, this is called the microservice based, like you have your database somewhere, like on anywhere, would it be cloud native or containerized or anything. So you have this kind of database with Flask API. Not just, there are multiple different currently in the current organization in which I'm working on. So there are around two 200 APIs that are working behind the scene, 200 services that are working behind the scene. Okay, there are multiple vendors. Like right now I'm in a fintech, so fintech. I'm working on a fintech project. So in that there is this user like we have CIBIL score. Okay, CIBIL score. So it checks to that credit scoring. It has API to check the user's detail from credit score. Okay, raising request for credit score checking to CIBIL, Equifax, or Experience. So these are some of the then there is like email integration. Email should be validated. So there are a lot of things that going behind the scene. If we go deeper into the system design, there are a lot of things. There are like public facing APIs, public facing, like publicly accessible APIs that can directly accessible over the internet, though there are some kind of checks and balance that are required. Then there is SSO. When we integrate our applications with a single sign on, so single sign on would mostly require, like there is in single sign on there is a user is sitting between and then there is one what we can say, like there are Okta. Okay, Okta and some of the services, some of the vendors that provide single sign-on as a service, so that uh, you have to integrate your application through that. So there are a lot of things that is running behind the scene. So like so this is the microservice based architecture. Okay, then there is monolithic architecture also. So what does monolithic means? Everything is in the same server. Okay, everything is in the same server. So sometimes what happen in monolithic, if my like backends get crashed or it went rogue. Okay, rogue means it consumes like it consumes all of the system resources. Okay, all of the system resources. So my database might also get hampered. Okay, and once the database is deleted, okay, once the database is deleted, whole application might get crashed. So there are a lot of things that goes by. Then we have seen RabbitMQ, we have seen Kafka. Okay, these are data streams. So every time when we are using microservices, keep your what we can say, tag it very well. Okay, use like these are some key points. Use official image, keep your image size small, clean up after build or everything, and leverage multi-stage build, avoid hard coding secrets. Okay, use proper tagging for identification. Then there is one more thing which is called regular scan, vulnerability scan for images. So how do we do that? So there are some tools we'll discuss. In fact we'll have practical sessions on that. Like Treevee we have. Okay, Treevee is Treevee is a comprehensive security scanner. Okay, it is used for container scanning. Then we have Sneak. In fact with Sneak team I'm currently uh, working on. They are one of the vendor for the project that we are connected to. So yeah, so Sneak is these are some DevSecOps tools. Okay, so we can use this. And there is I just have mentioned that there are some of the chances that your container might get rogue. Okay, so limit container privileges. So how can we limit our container privileges? So there is like I'll just show you in the Docker image. In the so these are some of the points that we'll be covering over. So right now if I just go into this like if I just go Docker exec -it full stack backend bash. Okay, so here who am I? If I run who am I have the root access. Okay, here you can see I have the root access of this particular application. And what I'll do, just one thing, rm or not like that, I'll just do one simple application, one simple, yeah, mv app to a. I'll just add one thing. Okay, here we are. Now let's go back to our terminal. We ran the, and let's just uh, where was that? We have created this API home is currently working. So if I just right now the application is currently working. Okay, right now the application is currently working, or I'll just say ps -aux. Okay, kill 9. What was the PID? This kill 9 1. I have killed this particular container. Let's just see if it is still working or not. It is still working. How so? Now it is killed. Still running. like right now I have I have so much access on this. Somehow it is my commands are like I'm using. Let me just check. Pkill. Pkill command work. Signals can be specified. It should be. I think pkill and kill. These commands are. So I will install kill. Yes, I can ux. Kill 9. Nine 1. So kill 9 PID. Okay, so right now I have full access. Okay, since it is the root account. But if I use like user, okay, user would be Hari. If I just create this, so Hari would have very limited access. If I'll just show Docker compose build backend. Hmm. Unable to find user, no matching entries in past WD. So this is one thing that we will be looking right now. So use like use the my user. I think user is it is the same. RTIR. Yes, position it here. Let's just up hyphen D front end backend might get failed. Error encountered. Yeah, unable to find user, no matching path WD something like that. So what has happened here? We haven't provided access to this user, this particular user. We haven't provided that kind of access in the container image. So that's why it didn't get updated. Okay, so let me just rebuild it and deploy it just to keep it as is. So with that, with root image, it is very difficult to use. So we can create a user inside that. We'll see in our later part. So here, let's just add. Okay, limit container privileges, and then there is with limitations, there should be limitations on, like I have provided the example that container sometimes goes rogue. Okay, so to prevent that, what we can use, we can specify resource limit like CPU reservations. Okay, and then CPU limit. Okay, and then there is CPU memory also. Okay, we can provide the storage, ephemeral storage it was, but it is more likely in Kubernetes it is used. So yeah, and then we have Docker ignore file. Like we already have seen the demo of this Docker ignore file. If we do not want our if we do not want our unnecessary files in the unwanted files in the container image, so it is better to keep it like that way. So these are some of the 10 best practices that we should follow in our container images. Moving forward, we'll be developing. So for Docker, currently these are all the basics right now. So first of all, cover the basics. Then moving forward, let's just work on. We already have worked on like Linux. We have Docker in our hand. Okay, and let's just see next topic. What do you want? Like CI/CD. We have Kubernetes. Okay, a lot of things that we can discuss. At least let's just cover the core concept of all of that, and then move forward to the production level or like advanced level monitoring, security, and everything. So For container images, we can what we can do, we can have we can just implement these best practices on that. So yeah, so as of now, let's just halt over here, and yeah, let's connect tomorrow for this. So thank you all, have a nice day.